Hello everyone, this is Meysam Favara, and this is a seminar, a short video on battery technology. I have been with Ozone for more than a year, and before that I had a lot of experience in CFD, cooling and thermal management with Ford Motor Company and Byton, which was an electric vehicle company. What are we? We are Ozone Engineering. We are an elite channel partner of ANSYS. We have been in the Bay Area for 17 plus years and 1,000 plus happy clients. We do sell ANSYS tools. We do customer support. We can do training, and sometimes we even do projects. We sell simulation-driven product development tools on multi-physics finite element analysis, or FEA, computational fluid dynamics, or CFD, and also electromagnetics, which includes high and low frequency. And we have been twice the channel partner of the year for the ANSYS, which is the parent company in the whole nation. Here is the list of ANSYS tools that we have, and we can sell it to you guys or support you guys on that. You see, it includes a lot of structural tools such as mechanical, LS-DYNA, ENCODE, and you name it. In fluids also, we have a large family of products, let's say CFD, such as Fluent, CFX, Forte, Insight, Chemkin, etc. On electronics, we have Maxwell and HFSS and a lot of model design. And on the semiconductor also, we have some tools and some on optics. On top of that, we have some tools for material like Granta and embedded software such as Skate. And also for systems, we have TwinBuilder and Medini for functional safety. And as you see, as a part of ANSYS family, we are a big company and we have a lot of tools. So whatever you're doing, give us a call. We can recommend you what tool fits your application the best and can save you some time and money based on that. The outline of this presentation would be that first we'll do a market research, see where is the market going, what's the future. And then after that, we'll focus on new battery technologies. And following that, we also have some discussion on reduced order models and digital twins, which is a hot topic these days. In sequel, we'll describe BMS or battery management system and the ANSYS solution recommended for this problem. The next step would be to go over the system level modeling to see how to predict the behavior of a complicated system when you have a large number of components in it. And finally, in the end, to wrap things up, we will have an example of a battery pack with fan. As you see, in the recent years, there has been a lot of interest in EV and electrification, and it has been attracting the largest R&D budget that a lot of us have seen ever. For example, vehicle electrification is the most important one. It includes the auto industry, which is electric vehicles and also ground transportations. In auto industry, to mention on electric vehicles, they predict that there will be almost 300 billion battery and powertrain market by 2025, which is 5 years from now. And based on that, Volkswagen has committed like 90 billion R&D budget over 5 years. And this is while the 2019 R&D budget for it was total of 16 billion. As you see, this is a good amount of budget they put on this, and that's because they see the future and the technology is not ready yet, and it's still evolving and developing. And this is not just limited to electric vehicles and automotive industry. There's a lot of ground transportation, like for example, the electric locomotives and trains which are very expensive, maybe 20, $30 million a piece, and those also are being electrified. The other type of transportation which getting a lot of attention is the air transportation, which is aircraft and drones. They predict that maybe a little later, by 2040, it would be almost 180 billion market. And based on that, a lot of companies are putting R&D budget on it, such as Collins Aerospace, which put 150 mil on it for 3 years, which is a good portion of its 3.1 billion total R&D money. The other branch is the industry or industrial electrifications, which is mostly for, let's say, production lines and factories. It is predicted to be around 50 billion by 2025, which is a couple of years from now. And companies like ABB have put a good amount of money, as you see, for 100 mil. And finally, the last branch is the power generation, especially about renewable energies such as wind and solar. And we know that there is almost 2.5 billion R&D budget on it by top companies in that branch. Based on what I said so far, you see there is a good amount of opportunity in electrification. That's why everybody's focusing on it and doing research on that field. The electrification growth brings a lot of opportunities, especially for automotive, which is the biggest category. Even when you look at the numbers, you'll notice that it had the highest numbers regarding the budget. Electric vehicles are just 2.6% of the total market, but probably in the next 10 years, we think it's going to be around 2030, around 30% of the total vehicles. You see the contribution of each of the markets, like China, Europe, and US. China is definitely leading. They have the biggest growth in that field. After that, it's Europe, and after Europe is US, followed by some other countries, the rest of the world after that. The electric vehicles usually has three categories: BEV, which is total electric or battery electric vehicles; HEV, which is the hybrid category; and also plug-in hybrid or PHEV, which has the charging capability, and also it has hybrid capability on top of it. So both in one. What are the challenges that we have for electric vehicles? One of them, of course, is the cost, because they're highly regulated, and because of that, they got to pass a lot of tests to be able to sell. That makes the price of these vehicles quite expensive, especially that it's a new type of vehicles, and a lot of the things needs to be tested sufficiently to make sure it meets the requirements and regulations. The other issue would be the safety, especially as you know, battery is mostly like a very high energy electrode inside a flammable electrolyte. Because of that, it's quite dangerous. It could lead to a release a good amount of energy and maybe explosion and fire. I'm trying to see if I can. Unfortunately, it doesn't let me play it. And the other thing is the performance. As you see, the range continues to be the market driver, and also the fast charge is the market differentiators, as most people aim for long distance trips, so they want to have a car that goes longer, or if they need to fast charge it, they can do it in a shorter amount of time. And the other thing is the time to market, which is another challenge because it's difficult to hit the cost, safety, and performance schedule while technology is still developing. In other words, even if you plan everything the best way, the technology is not there yet. And as you see here, this is the safety issue. As I mentioned, there's a lot of explosions that we see in electric cars like Tesla and other brands, and that makes them safety critical. So we should be careful with that. But what percentage of the EV cost is the battery? We know that EVs are important, but why batteries so important? One reason is that 50% of the R&D expenditure is on batteries because that's the area which is not figured out yet. If you look at the cost of an electric vehicle, you see that at the moment, almost 48% of it is a battery cost. And compared to other cars, typical IC engine cars, the cost of other parts are quite similar. And we predict that by probably 2024, we'll be in the same category and the same range as the IC engines. And if you go further, maybe by 2030, the price of the battery will go lower enough that we can beat the traditional ICE cars, which is very promising. As I mentioned, there's a lot of research on the battery which is going on because it's the most expensive components in EVs. And there's a lot of new technologies which are showing up. For example, there's a lot of new generation lithium-ion batteries which are coming out of different labs and different startups, usually for high level of energy density and fast charge. And they try to increase the temperature range at which they operate normally. I remember when I started working in my previous company, that range was usually even like minus 10 till like 35, 40. And then when you listen to the new technologies of batteries, it becomes bigger and bigger. Now it's like minus 50 to 125, which is very easy to handle. It doesn't need much of an active cooling and heating. It's a very big range and you don't need to worry about it that much. And you want to make sure it has a very low self-discharge and very long lifetime. The other technology that is happening is the sodium ion, which it's mostly used for storage, not for EVs because its energy density is low. There's lithium oxygen, there's lithium sulfur, which has its own pros and cons. For example, it has light active material, high energy density, but they're still in the research phase. And the most promising one is the solid state, which sometimes is called the holy grail of the battery, which is very safe because it's non-flammable when heated. It doesn't use the same electrolyte, it's just solid, and it has a very high energy density. But still, it's in the research phase and it's not ready for mass production yet. I have brought some examples of this type of battery. As you see, this is a solid state. This is what you have in your iPhone. It's a 3 amp hour battery, which is typical lithium ion, and this is the solid state version of it. You see it's way smaller. The same thing for this one, which is a laptop battery. There are different companies and startups that work on it. I can maybe just, for example, give two. As you see, a lot of big OEMs like Volkswagen, I don't know, Conti, Stanford, or Ford, BMW, Hyundai, they put money in it because they really need it. They know that they need to have a better battery technology, and they know that solid is probably the future for that. To do a comparison, I can say that the energy density in that solid power battery is way higher. The density per volume or per weight is higher. The cycles are almost the same. The safety is much better. As I mentioned, the solid state is not flammable. The shelf life is usually 10 plus years, which is much higher than typical lithium ion batteries, which is typically 2 to 8 years. And the operating range is also higher. Uh, Based on all these metrics that I calculated, I can say that electric cars are pretty much waiting for a mature technology for solid state, and this is very promising. Toyota, which was the leader in this field, thinks that they'll have their first prototype in 2021, and then in 2020s maybe they give out some production cars. Volkswagen thinks this would happen for them just a prototype in 2025, and Nissan thinks the first prototype would be in 2028. Different companies make different promises, but honestly, I think at least it has 5 years or more to come to the mass market. As you see here, There are some companies, they have prototypes, they have some tests that up, and you see that the energy density is much better than lithium ion. Here is the different generation of the batteries that we were using. You see where lithium ion is and how much better than that. At least it's like twice or more compared to lithium ion. So the solid is really the promising category, and everybody's waiting until the technology is mature and ready for mass production. This was the first part of the presentation, or the YouTube short one. If you guys have any questions, feel free to shoot us an email. I'll be more than happy to answer you guys. Thank you and have a great day. Bye.